Good morning everyone. This is Chandrakala. Now we will continue our topic of relative density. We have already discussed density and its change with temperature and anomalous expansion of water. So now we will discuss the relative density. Actually, relative density is the ratio of density of substance or solid object, whatever you have taken, depends on that, solid, liquid or gas, density of substance to density of water, density of water at 4 degrees Celsius. Here this term is very important. That means while writing the definition you have to include these two words, at 4 degrees Celsius. Now there are two questions. The first thing is, if I will write it in the form of a formula, I will write it density of substance or solid. If you are talking about upthrust, then you can say solid. So here if you want to write down, you can write down here, upon density of water at 4 degrees Celsius. This is our concept for relative density. Now there are two things. First thing, why only water? Generally in physics we define anything with respect to a standard quantity. So we know that in CGS water has its value of density as 1. So it will be very helpful for us. So that means we have taken water because just as it is having one standard value. Next thing, why only at 4 degrees Celsius? This we have seen right now in the last class. Because at 4 degrees Celsius water has maximum density. That's why we have taken it at 4 degrees Celsius. Nearby this 4 degrees Celsius, that means below this and above this, we are not having any uniform concept in case of water. So that's why here we have taken only at 4 degrees Celsius, because the density of water is maximum at 4 degrees Celsius, and water only because it is having one standard value. Okay, so that means relative density is the ratio of two densities. So from here you know that it will not have any unit. So you will say that relative density has no unit. Why? Because this density will have a unit. If you are taking it in SI, then it will be kilogram per meter cube, and the water will also have the unit kilogram per meter cube. So they will cancel out each other. So that means relative density, since it is the ratio of same kind of quantities, so their units will cancel out each other. Therefore relative density has no unit, and as you know it is a scalar quantity, since density is a scalar quantity. So that means the relative density is the ratio of two densities with respect to water at 4 degrees Celsius. It does not have any unit and it is a scalar quantity. Now if you have to find out relative density, then it depends. See, it will not have any unit, so there is no point of SI or CGS whatever, but this density of solid will have a unit. So if you are taking this density of solid in SI, that is kilogram per meter cube, then here you will take 1000 kilogram per meter cube, because this is the fixed value of water. That means the density of water in SI system is 1000. So whatever you are getting here, you have to divide that by 1000, then you will get the value of relative density. Similarly, if you are having this density in CGS unit, that is gram per centimeter cube, then here also you will write in CGS unit, that is gram per centimeter cube. But in CGS the value of density of water is 1. So therefore the density, something divided by 1 will not make any difference. So in this case, if you are calculating it in the term of CGS, then the density of your material will be the relative density itself. The only difference is here the density of the material will have a unit, whereas relative density will not have any unit. Otherwise numerically both these will be same, because here you are having 1, but here it's not same. So that depends on the question in which unit they have given. Accordingly we will calculate the relative density. Definition we have already seen. One more thing we have to see, that is relative density we said is the density of solid upon density of water at 4 degrees Celsius. This relative density can also be explained or defined in the term of mass, that is mass of the solid object or body or substance or material what you have taken, whatever, upon mass of water again at 4 degree Celsius. Okay, so from this formula there is one more problem, that is what is happening here. You see, density is equal to mass upon volume. So instead of this density, you can write here mass upon volume for substance upon this for water. Density means mass upon volume, but this is for water. So if you are defining these for unit volume, that means if this is 1, this is 1, then something upon 1 will be something only, something upon 1 will be something only. That means from here you will derive mass of solid upon mass of water. Similarly, if it is not 1 but they are equal, suppose this is 5, this is also 5, then again they will cancel out each other. So this formula is applicable only either for unit volume of both means substance also and water also, or equal volumes. See, here two terms has been used in your definition, unit volume or equal volume. So if these both conditions are there, then you can calculate it in the term of mass also, otherwise you will need density. Okay, difference is given, we don't have to learn. First difference is definition of density and relative density, which we have already seen. Second thing is density will have a unit and relative density will not have any unit, because it is the ratio of same kind of quantities. Okay, now our next topic is we will see the relative density itself again, but in terms of or with respect to, let me write, with respect to Archimedes's principle. Okay, suppose if you are not having this density of solid or water and you are given weights of the objects, then how will you calculate? Already we have seen here. First I will write the formula W1 upon W1 minus W2. Nothing is new here, same we have learnt already. You know that when you will measure weight of a body in air or vacuum, it will have a particular weight, and that weight is this one. That means a body will have some weight in air, that is its original weight, slightly less than that, because original we consider in vacuum, but still it's okay. Then here this is loss in the weight, that means weight of the body in air minus weight of the body in water, because you know that as soon as you will dip your object inside the water, its weight will decrease. That means if outside in the air it was 50, then after putting it inside the liquid it will become 20. So obviously the weight of the object in water will be less and weight of the object in air will be more. So larger value minus smaller value, which is also known as loss in weight, right now. That means how much, or you can say the displaced weight, which you have learnt in the Archimedes principle. That means the volume, that means volume dispersed or immersed inside the liquid, that much only volume will be experiencing upthrust, or that much liquid particle will exert upthrust. That means no doubt your water body is how. So as soon as it will be submerged into the liquid, its weight will decrease. So that means here we will need only two things, that is weight of the body in air and weight of the body in water. So here weight of the body in air and loss in weight, or you can say upthrust. So that will be weight of body in air minus weight of body in water. Derivation doesn't include much things, since here we are having masses of the body. If you will multiply it by acceleration due to gravity, you will get it in the form of the water. Okay, and this is the condition if the body or your solid object is not soluble in water. Okay, then you can measure it with respect to water. Now we have one more formula. If the body is soluble in water, that means if it is soluble in water, then you cannot do anything in water. So there then we will measure the relative density with respect to any other liquid. In this case we will take one another liquid in which it is insoluble, in which solid body or object is insoluble. Okay, and for that we will need two things. First thing, now we will submerge this solid body into a liquid, and that liquid is not water, because in water it is soluble. So we have taken any other liquid in which it's not soluble, but still since it is liquid, so as soon as the body will move inside the liquid, this liquid will also exert one upthrust force. So that means as soon as the body will move inside this liquid, there will be loss in its apparent weight. So, to calculate the relative density by this method, we will need weight of the body in air as we were having there, same one, that is weight of the body in air and weight of the body in air minus weight of body in liquid. Okay, that is, in other words, you can say loss in weight, but along with that we will need one more thing, that is relative density of liquid. That means it should be already given in the question. See, this is the relative density of your solid object, this object which has to be submerged into the liquid. This is the relative density of that particular solid, whereas this is the relative density of that liquid in which your object is insoluble. So generally we will use this formula to calculate the relative density. Otherwise here we have one more formula, and that formula is weight of the body in air minus weight of body in liquid upon weight of body in air minus weight of body in water. Then we should have numerical value of this, that means loss in the weight. So from this formula also we can calculate the relative density. That means we have two things. If the body is insoluble, such as normally we are having, then you have to use the simple formula, that is weight of object in air upon weight of object in air minus water. And if you are having, if your body, solid body is soluble in the water, then we will need the relative density of any particular liquid in which it is insoluble. Then here also we will include liquid. Rest of the things we will see in next class. Thank you.